This is the BPM Health Jumpstart tutorial session, which will run for the afternoon. And I wanted to thank Robert Lario for putting in the time and energy to show us how this works, and also to Trezatec for providing the software playground that we get to practice in. So I'm Jim McClay. I'm an emergency physician and an informaticist. And I've been on a mission to help my fellow clinicians by automating clinical practice guidelines and healthcare my entire career. And currently I'm a professor of emergency medicine and informatics at the University of Nebraska Medical Center in Omaha. I co-chair the HL7 Interoperability Council, and I research into reuse of electronic health record data for evidence generation. And in my role as a clinical informaticist, I work with my local health system and my specialty society to digest new regulations and evidence and convert them into protocols we can use in patient care. And every time we launch a new protocol or a new project, or we try to incorporate care pathways from published guidelines into our EHR, we tend to ask the same question as we try to develop the solutions locally. And that question is, hasn't someone else already done this? And then we grouse a lot about having to custom build the solutions at our site. And I think anybody else in the clinical informatics community could probably reflect on that, having that happen to themselves. Now, I've worked in the healthcare data interoperability arena for a long time, and things are certainly improving. With the adoption of standards such as FHIR, Fast Health Information Resources, and the requirement for APIs with our healthcare information systems that are required in the 21st Century Cures Act. But we're still building our workflow solutions locally. And we found, especially with this COVID pandemic, that health processes and best practices evolve very rapidly. And our current practice of involving lots of disciplines in our professional society and policymakers in writing recommended protocols and then making the conversion to our local platforms and formats has just takes too long, doesn't go fast enough, doesn't keep up. And that creates a problem. And we cannot rapidly share and deploy our healthcare processes and best practices that are built at some place like University of Utah and then install it promptly at University of Nebraska. So, and then as we'd write overlapping protocols from different specialty societies, and this just becomes more difficult. So a few years ago, as in my role as a co-chair for the HL7 Emergency Care Work Group, we adopted a business process modeling notation from the OMG to express the basic workflow of patient care in emergency departments. And we used that basic workflow to communicate with other specialty societies and protocol developers to explain how components would work in the emergency department. So it's very typical for a patient's journey when they have an acute problem to begin in the emergency department. So patients with heart attacks and strokes and trauma, their first stop is in the emergency department, and we begin the care protocol that may go on for some time. And so we need to interdigitate with other specialty societies, our neurologists or our cardiologists. And so it would be really useful if we had a shared model of workflows and how we were going to model the various components of these care processes. And even better if we could do that development work at a higher level in our specialty societies and then rapidly disseminate and deploy those workflows and protocols to our local sites. Especially in specialties and in emergency medicine, where the physicians may often work at multiple locations and move between information systems. The object management group has extended that business process modeling notation to include more modeling notations that could be bundled up into an automated model of healthcare practices. And this has really become from other industries, and it's well in use. So today, we're going to discuss this rapidly developing solution to the problem of portable protocols and processes, and the BPM plus Health suite of linked model specifications for workflow decision-making and case management map directly onto the needs of the healthcare industry, and can help us define our shared care pathways and guidelines and protocols, and then distribute those to our local sites. So that's the problem we're trying to solve, and why the BPM plus Health suite of tools is so interesting. And I wanted to turn this over to Robert Lario, who is going to walk us through how this actually fits together and how, as a modeler for healthcare processes, we can use these tools to really clarify the details and provide standard models. So I say, take it away, Robert.
Thank you. So my name is Robert Lario. I work for the University of Utah and the Veterans Administration. I co-chair the Healthcare Task Force at OMG, and I also co-lead the methodology group, part of the BPM Plus community. It wouldn't be a presentation if I wasn't having technical difficulties, so you'll see me kind of playing with something, trying to get some things to work, but I'll make it work with what I've got. Here's just a really rough agenda. It's a long afternoon. I will try to stay very close to the top of the hours when we start these different modules. For those who maybe don't want to see so much on BPMN, but want to learn a little more about DMN, come back around 3 and also around 4. We'll have breaks, probably in between each section, probably about 15 minutes or so, let people run off, get a drink, and attend other issues. And then we'll probably wrap up pretty close to 4:30, and there'll be time for questions. We've got, as I said, plenty of time. All of you who are on this on this meeting should have received an invite to access the TriZetech tool. This is a hands-on discussion. I'm not going to be just presenting slides to you. We're going to take an existing clinical practice guideline, the chronic kidney disease, a very small part of it, and we're going to deconstruct it and move it out of the PDF cheat sheet and move it into the 3 different respective methods of BPMN, DMN, and CMMN. I put in the chat the link to the PDF in case you haven't grabbed it yet. I would recommend that you do. It's make it easier for you. You'll be able to highlight things in the PDF, cut things out, and paste them into the modeling tool. It'll save you some time and headaches. And for those of you who don't have access or had issues gaining access at the end of this section before we actually move into the actual modeling, we'll have a few minutes to sort of help out anybody who is having some technical challenges. So if you haven't got access, have issues, please put that in the chat, and people will be watching that and try to help you along the way, but pretty sure that by the time we get to the next section, we'll have you all sorted out. Let's see. Okay, so these are some just administrative things. As I said, you all should have access to the TriZetech tool. thank you for the TriZetech. This is a commercial tool. It's a full functional environment, and you've been given 10 days access to the tool. You can, after this meeting, you can go in and create some other models, play, do whatever you wish. If you wish for a longer access, you should reach back to TriZetech directly. They can set you up. And again, here's the guideline that we're going to be using, and so please make sure you have access to that. It's helpful if you have two screens. You'll see me moving back and forth between the two. I usually have on one screen, I'll have the PDF, and the other screen, I'll have the modeling tool. So one of the questions that's often asked is, how do we do this? How do we build models? Where do we start? And so I feel compelled to sort of back up and kind of explain some of what's happening, some of the thinking behind the process of building models. And so it's a little bit of theory, not going to spend a lot of time on it, but just kind of give you a background and some references if you want to, excuse me, want to go on and read some more. There's a famous paper written by this Dr. Ogden, The Meaning of Meaning. It's a great name for a paper, The Meaning of Meaning. And this notion of a referent triangle, many of you might be familiar with it, but in this paper, he talks about the fact that there's things in the world, which he refers to as referents. Those are the things that exist in the world: cars, trees, businesses. And then there's symbols that we have that we associate to those things. So these are in our case, we often we can think of these symbols as language constructs. So the word car is a symbol that binds to something in the world. And when I say the word car, it will register a thought in your mind. So it's the triangle of things in your mind, things in the world, and the way we reference them. And so when you're thinking about things in the world, you're thinking about things, but when you want to communicate, you have to give me a symbol. And so even natural language, this process of me speaking to you, is I'm conveying these audible signals that that you are dereferencing them into your understanding, your conceptualization in your mind, and you're forming this internal dialogue and mental imaging of what's being said. So a silly diagram, but here on the right, this notion of a stop sign. We see this notion of red, or we see red, which all of our senses are bringing in constructs. You have audible constructs, things that you hear, things we see, even your sense of touch. These are all constructs that come in and register in your mind for something. So we have the notion of red, and in our mind we have this concept of red. And so that's sort of how we build models, right? So we have these things in the world that we want to communicate to someone else, and so we bind symbols to them. In our case, we're going to be using symbols that are showing the notion of a process, or symbols that show the notion of a decision, and they're graphical in nature. So we're taking things in the world, we're going to be binding them to symbols and things that we're thinking about, guidelines that people have built, they've thought about best practices, and they've expressed them using various symbols. So another interesting paper, which kind of expands on that, there's a lot of work around this, but this is a good reference, is taking that triangle a step further. And this paper here, this notion that you have these things, these conceptualizations, your world knowledge that you have, and these concepts you have, on the left-hand side is things that we have in our mind, and these are the symbols, these conceptualizations, these are the concepts, and we associate those to the symbols. In the case, they're a language, which is a collection of symbols, and we use this language, in this case English or Japanese or any language, and we bind the constructs to those symbols and then create these specifications. So essentially, when I'm speaking, I'm giving you a specification. When we build our models, those are all specifications using the languages we're using. So in a slide, you know, we see this in our minds. We have this notion of a stop sign. I'm thinking about a sign. I'm thinking about a color. I'm holding this concept in my head, and then I bind that to a construct in a language that I'm going to as you as an audience, I believe you'll understand. So if I said aka, which is actually the construct in Japanese of red, unless you already knew that or spoke Japanese, you would not understand what that meant. So that would not be a good choice for me to use as a construct. But I could use the word red, and I could build up a sentence and say the sign is red. And at a very high level, this is what we're doing. We're building these models. We have stuff in our head. We have concepts. We choose languages to express them. In this case, we're going to choose the languages of business process modeling notation, case management modeling notation, and decision modeling notation. And I'm going to take these languages, and I'm going to create these specifications or these models. So here is an example of a specification. And what's interesting here is it's a little different way of thinking, but if you back up and what languages are actually being used here, or what constructs are being used? And the obvious one is English. How do you go beyond the smiley faces scale? So that's some English. There's some symbols here: no pain, worst pain possible, worst possible pain. But there's other languages here. There's color, right? This whole spectrum of color, of blue to red. These are colors, visual spectrum, the language that are bound to some meaning, some concept. And there's an ordinal scale, so there's numbers, there's also positions, there's spatial orientation. All of these are ways of communicating knowledge in different languages that the authors have brought together to represent this. And so they use these languages to express this idea of a pain scale. So how does that fits in right here? So there was a bunch of languages that were chosen: color, spatial orientation, ordinal numbers, some words, and they created this model. And then this is given to you or to somebody, and we're expecting them to be able to dereference this, to know that this is red means pain and blue is happy. And that's part of the problem when we consider building models and trying to communicate is disambiguation and making sure that what we produce as a specification, when it's received, that it's a high degree of certainty or belief that they're going to understand and be able to interpret what your intention is. And that's often problematic, and there are various reasons for that, but one of them is just by choosing poor methods or languages for which to convey the knowledge. So we're going to look at this particular practice guideline. There's a much larger definition of the practice guideline for chronic kidney disease. I've put the link to this in the chat, and we're going to use this and deconstruct it. It's kind of helpful. It's already got it set up, but as we go through it, we're going to find that there's some areas here that maybe aren't so clear, and some assumptions that the authors made that maybe aren't the best assumptions. But as we start deconstructing this, as we start looking at these constructs, these symbols, right? We're looking at the symbols and we're trying to figure out what the referent is and what was the concept that was in the heads of the authors. So this is the symbols. This is the result of the assembly of their conceptualization around this particular problem in these models, visualization of it. So here we have languages that we're using here are natural language. There's some shapes, right? These mean something. Squares, rectangular box or rounded boxes, these irregular shapes, there's arrows, and we are inferring what we think the author means by this, which inferring is not always the best thing when you're especially trying to deal with clinical knowledge. We want it to be very clear and concise. So, but we have to figure out what these things mean so that we can re-represent them in a way that I would argue is a little clearer and further disambiguated. There's always an opportunity for misunderstanding, but I think the models we'll produce are going to be even clearer and more concise. And so here in a picture, we got this idea in our heads. This maps into a bunch of concepts. We have to choose languages that represent those things in our mind. So here is the language of BPMN. I'm sorry, there's a spelling mistake there. There's two P's. There's this graphical symbol of a circle, which actually has some semantics and specific meaning in the language of BPMN, and it's going to represent the notion of an event. So in my mind, when I need an event, I'm going to use this circle. And when I have sequences, another concept in my mind, the sequence between activities, tasks, I'm going to use this line. And I use this language, these constructs, to assemble some specification. So conceptualization, if pregnant and has cough, test for influenza. I have a start event, 12-week checkup. If they're coughing, I'm going to test for influenza. I'm going to check out. Just a silly example of where you've got this conceptualization, concepts, languages, and then into a specification. And that's what we're going to be doing. In part, we're actually going to be reversing this a bit. We're going to actually start down here with the chronic kidney disease. We're going to deconstruct it into the languages that we see, into the concepts that they're supposed to represent, and then we're going to cast forward into these respective languages. So this is essentially what we're going to do. We're going to take this little cheat sheet. We're going to look at the concepts and constructs. We're going to find what the concepts are, what's trying to be communicated. Then we're going to choose the best language of the three that we have in our portfolio, and we're going to recast them in with those languages, producing the respective specifications. I always like this slide. I teach this class at the University of Utah, and by the time I get to talk about this section, we actually go into a little more detail. It's too late for the students to drop, so they're stuck. So the methods that are languages that we're going to be focusing on here are business process modeling notation, case management model notation, and decision modeling notation. These are all specifications, languages that are managed under the object management group. And this is what we're going to be talking mostly about through the remainder of the day. BPMN, business process modeling notation, as I said, is a standard at the object management group. Another typo. It is a language, graphical language, that is specifically focused on articulating processes, and often thought of as business processes. It has a very controlled vocabulary. The graphical symbols are the constructs that bind to very specific things. They have their meaning, and when someone else in the world looks at the model, they'll interpret the model in the same way, at least hopefully in the way that you meant it to be, where the squares are tasks and sequences and so on. Here is the spec. If you want to go to the spec, I'm actually going to step out in a minute and show you the Rmg site, just so you know where to go and look for these things. There's a wealth of knowledge, sometimes too much. You got the forest and trying to figure out where the tree is you're looking for. I'm going to show you how to find the tree. These specs are terse. They're designed for tool vendors, but often there are sections that are very readable and useful for people that are trying to build these models. It kind of explains the semantics and how things fit together. It's free. I'll show you how to get to those. CMMN is the case management modeling notation. This was a spec in response to some of what was perceived as limitations in BPMN. I'll talk a minute about that in a moment. It's a method for representing case management. The most notable part of the case management concept is that you describe a series of activities and tasks that a knowledge worker should you expect them to engage in, but you leave it for them to decide which ones to do and in which order to do them. You can add some sequencing if you wish. You can also say some things are required, some are not. But essentially, you're leaving it to the knowledge worker to decide what they should do in terms of sequence. So many of you, I imagine you've all been to your primary care physician and your care provider, and you go in and they bring you into the room, and the care provider will begin to take your body temperature, your blood pressure, maybe ask you a series of questions. Those are all things that the knowledge workers should engage, but they're choosing the sequence in which to do them. So you could use case management as a way of expressing the things that they're supposed to do, but not tell them necessarily the sequence. The final method that we're going to focus on today is DMN, Decision Modeling Notation. This is a way of visually expressing rules. You can think of them as, in most cases, as if-then rules, and I'll explain the structure of this, what you see here, this table. But you have the concept of a rule, which has the sort of the antecedent or the if part. If this part is true, then you have the conclusion, and you can assert things. And so it's a way of coding decision logic. And we'll talk a little bit more about that as we get into that section. So here's a quick view of BPMN is around processes, activities, CMN is around cases and events, and DMN is around decisions. And question often comes up is, when do I choose one versus the other? And it's not often the case where you don't just have to choose one. These methods all work together. You'll see how we're going to use BPMN as sort of our overarching method of expressing the overall control flow. We'll delegate to DMN, Decision Modeling Notation, to do the decision making, and we'll delegate to CMMN to do some of the case management activities. But we could have very easily used CMMN and express little processes in BPMN and DMN. So you can mix and match. BPMN can call CMMN, which can call all BPMN, and CMMN can use DMN. DMN is not what you're not going to use DMN to drive CMMN or BPMN directly. The decisions that come out of DMN, out of a decision, could affect the flow of BPMN and CMN. Another resource that I want to make you aware of is the BPM Plus Field Guide. We started some years ago trying to look at these three methods and come up with some guidance and some ideas to help give some insight on how to use these methods. The first was published in 2016. We published a second version in 2019, and we're currently working on a third. The guide is broken up into three sections. The first section is if you've never seen these modeling methods, this notation, it gives you a very, very high level perspective of what a task looks like, what a sequence line is, what these things are. It's not meant to be a tutorial. It's really just to give you a 20,000 foot view of some of the major constituents in the respective languages, and just kind of give you the ability, if you read that section and you saw them, you saw one of the models with these methods, you would have a basic understanding of what the model was trying to say. The second section is the first section was the reader. The second section is sort of for an individual who knows BPMN, CMMN, DMN. And this second section is to give you, the reader, some ideas on how to use these methods of best practices and patterns to represent things in healthcare. The third is the section is around if you're an organization and you're going to ingest these models, what are the things you need to consider? So when we build our models, you can build models at a platform independent level, which means it's agnostic of how you're going to deliver it in the enterprise. You're focusing primarily on the guidance, the logic, the business logic, the clinical guidance in your models, and you're not putting in your models issues around your organization. If you're an organization that has an EHR, you would ingest these models differently than if you were an organization that was greenfield and you were going to use a process engine. So, so the platform independent models are agnostic. Platform specific models are models where you've taken a basic model and you've evolved it for your particular organization. And so that's what this third section is about. A couple of things I also want to make you aware of is that in addition to BPMN, CMMN, and DMN, as we were working with these methods, many of us use these in real life and work on real problems. We started to see that there was a need for some additional support. And so we started several years ago an effort to come up with 3 other methods, standards that are actually going through the OMG process presently. When we graduate and become specifications, they will be added as first-class citizens to the family of BPM Plus. One of the first is we call shared data model and notation. This is a specification around how to create a very simple data model that fits in with BPMN, CMMN, and DMN. As we were working with BPMN, for example, and we were describing the kind of data that we needed, that same model would be needed in DMN and CMMN. And so we wanted to come up with a standard way to support that. And so that's what the shared data model is. We're not trying to invent a new modeling methodology. We're not trying to define healthcare models. What we needed is a way that when we build a BPMN model, perhaps like in our case, chronic kidney disease, we need to be able to create and be able to express the types of data that we need in order to support the process, to support the decision making, and also which will get adorned through the decision making process, what that would look like, where the data is, how it comes, where it resides at rest, and how you get it is outside of scope of this. The second is this notion of a packaging. So the business knowledge package model and notation. Think of this as a manifest on the side of a box. If you can imagine a wall with all these boxes, and on the side, excuse me, is manifest. And on the manifest, it tells you what's in the box, when you should use the box, what you need in order to use the box successfully, what the intent of the box is. That's all the packaging around that. And for those of you who are familiar with the clinical practice guideline, you can imagine there are actually, we will see here, we're going to build 3 different models that supports this one part of the chronic kidney disease problem. Excuse me. We need a way of putting that together into a body of work and have have a systematic, programmatic way of interrogating and knowing that when to use this particular guideline. Some of the things that you might include in the notion of the package is, what are the resources you as an organization have to have in order to successfully use this model. So if you're in emergency medicine, and it is a guideline that's been designed and built for emergency medicine, there are certain facilities that you're going to need to have available in order to successfully use a guideline that's designed for an emergency medicine environment. And that's the intent of the business process modeling notation. And you can imagine that problem exists in any domain. As you build all these complex models, when do you use them? How do you, what are the resources, and what's the exclusion criteria? What's the effect if I use these models? The last is Pedigree and Provenance. This is actually an effort that's been that I've been involved with John Butler for, well, going over 5 years. And this is a specification around the epistemic information about the knowledge that you're doing or what's happening in the enterprise. It's the farm to table problem, right? You could use BPMN to describe how an apple got picked, put on a truck, went to a plant, was processed, was put into a pie, was frozen, and ultimately delivered to your local grocery store. BPMN provides a systematic way of expressing that, a systematic way of sharing that information. You can imagine an ecosystem of participants that participate in some kind of process of things that have to happen. BPMN allows the expression of that provenance and pedigree of things. BPMN, the RFP was issued in December of this last year, 2020, and yesterday the first review of the initial submission was completed. It went very well. Situation, shared data, and business process modeling. These are still in an RFP stage. They're being reviewed this week, and hopefully, if everything goes well, they'll be issued as RFPs at the end of this week, and then we'll move into actually developing the solutions to those. These are open communities. Anybody who's interested, wants to learn more, you can reach out to me or contact the object management group, and they can put you in touch with the individuals that are involved in these tasks and activities. Okay, so we're going to be, you've heard me mention the notion of a clinical practice guideline. The Institute of Medicine, IOM, they published this this sort of document that says this is what we think a clinical practice guideline is. These are the major pieces. These are how they, this is what you should have in them in terms of the authors and the major sections. But the one thing they didn't do is give guidance on the language to express clinical knowledge. And that was not, so that it's really up to the developers of the guides to do. And so what you'll see is, even in our chronic kidney disease, you'll see things like natural language, which makes absolute sense. Then you'll see tables, you'll see these sort of funny flow models. And we've been around enough to know what a table's supposed to do. We know rows and columns. But the fact is that we have to infer what was being implied by what we're seeing, and that's a problem, right? And I think in my next presentation I'm going to add a slide. There was some famous paper or things, errors in medicine, and I think that, I'm trying to remember the number, but it said, I think that it's like 400,000 medical errors occur, I think, in the year that the paper was published, or something. I have to go back and pull it. It's quite significant. And there's all kinds of reasons why we have medical errors, but one of them is often cited is this notion they call a lack of interoperability. And those are in technology. We always hear that word, interoperability, but interoperability is it's just the communication between two systems. So right now, hopefully I'm interoperating with you. I'm creating these specifications, I'm sending them to you, and you're taking them and you're unwinding them, and you're inferring what you think I'm implying. And that interoperability, that level of improved interoperability, or the measure of interoperability, is how the fancy word is how homomorphic is your understanding on the domain of discourse that we're having with mine. Is I'm sending this information to you, and you're getting and unwinding it, and and if it's the same, then we've got a high degree of interoperability. But one of the cited issues on medical errors is a lack of interoperability, and there are a lot of reasons why that could be, right? But one of them is just having poor languages to express. And an example that I like to use is, if I said iris is blue, that's a very simple statement. But the challenge there is that you have what's called construct overload, where the notion of iris it could be a person, it could be your eye, it could be a flower. There's a Gata iris, the rainbow, and then blue could be an emotional state. It could be a color. It could be an emotion. It could be an emotional state. It could be a temperature. And so that's the challenge when we look at get guidelines, for example, is there's statements that are made, and as authors we think they're completely clear, but when the audience gets it, they're bringing their own background and knowledge to it, and they're interpreting it. So the one guideline that I worked on was influenza and antenatal care, and in that guideline, they have the construct, the words respiratory distress three times, and each time it turns out they meant something entirely different. And not only that, depending upon who the reader was when they read those words, respiratory distress, in the context where they were being stated, if you're a respiratory therapist versus an OBGYN, they interpreted that information differently each time. So you had a guideline that was anything but clear. And one of the number one cited reasons for why clinicians and care providers don't use clinical practice guidelines is because they think they're inaccurate, they have omissions, and they have errors. So our goal is to come up with methods for removing that ambiguity and improving clarity. So at this point, we're going to take a short 15 so minute break, come back at the top of the hour. For those who have any technical challenges, who are unable to get access to the environment, please raise your hand, speak up, let us know, and we'll help you get connected. Otherwise, I will start up again at the top of the hour in about 15 minutes to get into the first section, which is the BPM plus. Thanks for coming back. We had some questions that I wanted to in the chat. We had one question. Are we aware of any other Germans involved? Yes. Hope that was helpful. Yeah, reach out to the OMG folks or to me directly. I don't want to just be putting people's names on the video and on the chat, but there are people in Europe that are involved. Be glad to try to connect you up with those individuals. So reach out to OMG or to me or anybody in the BPM Plus community. We'll be glad to try to connect you up. Another question was around the use of BPM Plus Health, the BPM Plus in the WHO. We've had participants from WHO in the Jumpstart as well as the BPM Plus meetings at large over the last couple of years. I'm sorry, I can't recall names at this point. Again, that if you might, the OMG folks, they keep track of their attendees and all. They might be able to connect you up with those individuals. I have seen some requests for proposals come out from WHO where they are starting to use these methods to express their requirements, particularly using BPMN. And so I think there is some uptake for it. What's interesting is, I think is interesting is not only can you use these methods to express requirements, you can, the response can also be expressed in these methods. But as you'll see when we get into the deeper into each of the three, they have simulation execution semantics. So we can actually run them in the tools, all the major tools that support these methods. You can run simulations. And so it's a great way to validate the models, to sit down with the subject matter experts and sort of play what if scenarios with them right there in front of them, right there, and just sort of work through and see how things are going to work. And then, and also there are tools out there where I don't want to overstate it, but you can deploy these models into the environment and they execute. So the languages, if you have the right level of specificity and detail, essentially you're almost programming. You don't see that necessarily as you're building these models, but behind the scenes is a very, very concise syntax. And if you fill everything out correctly, which there is some skill there, but you can run these models. So, okay. Any other questions? Okay. So you see my screen, I hope?
Yes.
Okay, great. So you all should have access to the tool. I think we got everybody situated. This is the guideline that we're going to be working with. This is the big guideline. You have a cheat sheet which looks like this. Everybody, I recommend that you
Sorry,
grab this.
Robert, there was one more question in the chat.
Okay.
By Bruce.
Could you briefly discuss how BPM Plus can interoperate with HL7, especially if it's, sure, yeah. So the question is from Dr. Bray, wants to know how BPM Plus plays along with HL7, and the answer is quite nicely. BPM Plus, although the 3 languages that we spend a lot of time with are derived in the OMG community, we are agnostic. What we're looking for is fit for purpose. And for example, CQL, clinical quality language, is a method for expressing decision logic that comes out of the HL7 community. It is a great language, very fit for purpose, well designed, and it's great for expressing clinical knowledge. You have to make a choice on what fits for you, DMN, decision modeling notation, or CQL. There's been some work looking at those 2 languages together. For instance, if one question was asked is if we build a DMN model, decision modeling notation model, and can we turn it into a CQL model and vice versa? And there's been work on that and some success. There's actually a big effort under this CPG on Fire, a lot of work coming from Mayo where they're using what's called model-driven architecture, which is it's a pattern where you express you design your models and then you transform them into other models. And so yeah, CQL is just another modeling language, another language, and so there's transformations to convert into one and back again. And they're looking at that and how to go from design where you build a model, translate it into CQL, deploy right into your runtime environment, and be able to execute. When you look at a clinical practice guideline, there are different types of knowledge that are present. There's process knowledge, there's decision knowledge, there's pedigree, provenance, epistemic knowledge. The question you have to, do you try to find one language that can do everything, or do you choose languages that are fit for purpose and mix and match? And so that's sort of part of the discussions when you're looking at CPG on Fire, where the languages fit together. So you could use, for example, so CQL is great at decision logic, but doesn't handle procedural process knowledge. So you could have a BPMN model, and that we'll see in our model where we're going to use BPMN, and then we're going to call a DMN model to do our decision making. You could use BPMN to articulate the process which has to occur in delivery of care for a guideline. And then when you hit decision making, it actually delegates to CQL, and CQL does all of the decision logic and then returns back a value back to BPMN, then BPMN takes it forward. So these all should work well together. Fire, the Fast Health interoperability resource, right, is a service-based protocol. So it's using REST. You can, in BPMN, there is a task that's designed for calling out, and so you could have a BPMN model that calls to a Fire resource to grab data and pull in. There was if time permits, I'll show a little bit of some slides from a presentation on something that we did some years ago where we used BPMN and with CDS hooks and Fire all together. BPMN did all the control logic, and then we called out to a Fire resource, grabbed some information, pulled in the DMN, did some decisions, and then pushed some CDS cards back, all using open source tools. So belaboring the question is that our hope and goal is that these all work together. And anything we have in BPM Plus, we hope HL7 can benefit from, and we will certainly pull in and try to figure out how to, the resources that are produced by HL7, how to make them work with these methods as well. Okay. Careful with questions. I have long answers. Okay, so here's the guide. You all should have this. Again, grab it, make your life easy. You could be able to cut and paste things out of this, save yourself a lot of typing. This ultimately is what the final product could look like. It goes through and articulates what that little cheat sheet card has there. I want to show you some context. So this is a BPMN model. This notion of a start event, we'll talk a little bit about that. Tasks, sequences, gates, signals, events, catching and throwing. We're going to talk about these different things. Notice here in this model, this is in our CPG, we have this, there'll be a decision that's trying to determine what is the stage of chronic kidney disease. If we look back at the guide, I think it comes out of this right here, stage of the CKD. And so you can, this is where it manifests in our model. And this is where you'll see here, where we're going to create a DMN model to replicate that logic. And so this task is what's going to delegate out to DMN. And we're going to create this DMN decision table here. And a little more details. This is what we're going to see when we get into the DMN section. And then there's another, if you look up front towards the beginning of this process, you'll see that there's another task which delegates out to CMMN. That's the little folder here. This little notion of a vanilla folder is the case. And that's the symbol that says this is a CMMN task that will be delegating to CMMN. We'll see a CMMN model that we're going to create from the chronic kidney disease guide. And this is what it's going to look like when we're done. So you all should be able to get to this site, go to this link, log in, and now we're going to jump in. So when you log in, you'll see something that looks like this on your screen. Your friend is this little 3x3, these tile thing. If you click on that, it's going to give you access to the tools that are relevant to what you're doing. You're going to see some things more than what I have. I have access a little bit more, but essentially you click on the tile here, and up will pop this set of tiles, and you want to click on the workflow modeler, big B, it's blue.
Sorry to interrupt, Robert, but Bjorn asks, a case task in BPM and does not yet exist, does it?
A case task. Can you have in a BPMN model and show a case model that's going to be called? Is that? I think the answer is yes, you can. Let's see. I'll back up just for a second, but then.
If I may interrupt, you just showed a BPMN diagram using a case task, and I'm not familiar with that activity type. I thought it's not yet available and it's something for future versions of the BPMN, but maybe I'm not updated.
You know, so what you're asking me is the case model standard within the BPM Plus specification? And I'm going to have to tell you, I do not know for sure. So I'm going to have to go look. I just assume that given where we are, things that it is, but I might be mistaken.
Okay.
I know the modeling tools, a lot of them support this, like Commanda and of course this tool and others support the ability to say that this is an activity is a case activity. But if you're asking, is it standardized? I'd have to go check to be sure.
I just remember using call activities to call upon a case model, but never mind. I don't think it's important right now.
Okay, well, we can check and see. Okay, so if you clicked on the B, you should see something that looks a little bit like this. And I'm going to, now here's where the challenge I'm going to have with the tool. Things aren't behaving for me, so let's see. I want to catch up with you guys. Let's see here. Yeah. So you're going to click on this button there. You can see the tiles, and I'm going to click on the B. So you'll see a blue screen come up, and might take a minute. It's loading everything. One thing that's nice is that it's, if something goes badly, you can just close your tab and open again. I would recommend saving often. So saving is, if you see up here in the left-hand corner, you see File. So this is opening up with the last model that I already had open. It's the default of the tool. So if it responds. Yeah, it's thinking. There we go. So I had to get a new palette, a new sheet. So click on File, and then you can do Save As, and then you can just save your model as you go, and you can put it in your folder. I guess I should have taken a moment just to talk a little bit about here. You should see your name. You'll see these folders. These are just for you to catch up. If you want to lean ahead, you can, but try to work with us, and maybe if you get stuck, you can choose these. So these are all models in various stages. So if you finish the BPMN section, you can open up this model, the next stage, and finally the third stage. You can see all of them. Yeah. So let's come back to, I will tell you that this is really a class that's set up to be done in person. In the past, we had two projectors, one with my slides and one with the actual tool, and so it takes a little getting used to trying to do this remotely like this, and so I hope you bear with me. Okay, so the first thing that we're going to do is on the left-hand side is your palette, and these are the things that you can draw on your canvas. And so in a BPMN model, a good BPMN model always has a start event and an end event. So we know we have a start, so we're just gonna click on this, and then we're gonna drag it over and drop it. And we're just gonna throw down some stuff to get started. And so just to familiarize yourself with the environment, if you click on the event, you'll see these little anchors, and if you click on those, you'll get a little pop-up menu, the helper menu. It's a quick way of just threading together a model. So click on the little arrow, choose a task. If another way to do that is you could just drag a task over, and you can also grab a sequence line and connect them. There isn't a right way. It's whatever you're comfortable with. And then go ahead and drag another one over and drop it. So what you'll end up with, essentially, you'll have a start event and two tasks. So tasks are things that get done. And the sequence line is showing you the dependency, right? That says that we have this. What you see here is this notion that we're going to start. We don't really know how we're going to start yet, but we're going to start. And then we're going to do something. Don't have any words for it. We're going to do a task. And then we know there's another task that follows that task. And so the sequence lines help us keep track of the ordering and sequencing. Now, that's so back at the beginning, I said I was going to talk a little bit about case management modeling notation and how it came about. BPMN is great if you have a very deterministic process, that you know that task one is always going to follow task two. It's very deterministic, but the support for sort of ad hoc tasks, ad hoc scenarios, was not believed to be rich enough in BPMN, and CMMN was seen as a solution to allow that kind of ad hoc sequencing and to more empower the caseworker. There's often a lot of debate about that, and maybe you can read that in the way I'm mincing my words, that you can use, there's a lot you can do with BPMN before you need CMMN, and there are people in the community that are not necessarily in agreement that about the need for both, but that aside. So the sequence line is tasks, sequence, and events are the primary things you're going to be dealing with when you're building a process model. So if you open up your CPG, the first thing is we notice that we have this, let's see if I can, this is, yeah, going to be challenging. Where's my CPG? You know, let's look at it real quick before we start getting too far. We see here that there's obvious, well, we're assuming this is the start. And I think it's a fairly good guess. But that's one of the challenges when I go back to disambiguation, right? We're assuming this is the start. And it's probably an accurate and fair assumption to be made. But when we're trying to specify something like this, clinical knowledge, we want to remove as many assumptions that we're going to place on the viewer as possible. So, you know, this is where we're assuming this is the start. We have this notion that patient at risk for CKD. So go ahead and highlight that. You can just copy the text back to my model. Pull over my task event. I click on that. I'm going to create one task to it. And then what I'm also going to do is I'm going to use a different method. I'm going to go over to the taskbar or the palette, grab a task, pull it over, put it right next to afterwards. Now I could click on this and choose the sequence line to connect. See how it does that for me? Right, just by clicking on that blue line there, or the blue caret. But I'm going to pull it from my palette. So I'm going to pull yep, it's not the sequence line.
Mark Nielsen just posted a question in the chat. You can unmute Mark if you wish to pose it.
Give me 1 second. So here I've got the sequence line. You notice it's in red. When I put the tail on the first task, you'll see how it lights up. The little red dots are the anchor points where the tail will grab a hold, and I can let go. So you can see it's still red, so it's not connected. I can grab the head of it, move it around, and I can bring it into this task here and connect it up. Okay, question.
Just a question about the example that you shared about the CKD. Is just wondering about that patient at risk for CKD. Is that can that be a clinical decision? Can it be a risk predictive risk model? And what kind of feeds into that to determine if they're at risk or not?
Yeah. I don't know. That's the challenge with this, right? Because all it says is it starts off with patient at risk for CKD. So something has happened before this. I don't know what it is. Now, the answer to your question is yes, you could put things in front of this that would, there could be some kind of calculator or some other process that something happened where it was determined that this person was at risk and you want to drive them through this. But the answer to your question, from what we see here, I don't know the answer to your question in terms of how we got here. But we can do things. Go ahead.
Yeah. And it's more around what's likely. I understand that for this example it's missing, but just what's possible in
I would
process. So
yeah, well, give me a second and I'll come back to some ideas on how this might kick off. Which is one of the things in BPMN, we can use this notion of a signal, and I'll explain that in a moment. So give me 1 second and I'll circle back. So go ahead and I'm going to copy this text here, and I'm going to go back to my model, and then I'm going to click on this event. This is a start event. And I'm just going to click on it. I'm going to paste this, as I am too lazy to type. And in addition, I have very fat fingers. As my girlfriend says, I need to stop eating donuts. So this is the start. Now, I don't know who spoke a moment ago. They were talking about how this might start off. Right now, this just says there's a start event, and it's not wired into my system. If I deploy this into a runtime environment, forget about the fact the rest of the stuff isn't specified. How does it start? What causes this to happen? If you click on the event start, so I'm going to differentiate. I'm going to pull something else over, and then I'm explain these. Put this right next to it, right here. These look very similar. There's a circle and a circle, right? Both of these are events. The lighter circle is the start, and the ending circle is the end event. And in BPMN talk, there's this. We use this notion which we call catch and throw, and just in the metaphor of a catcher and a pitcher. The lighter circles events that you're going to see. So an event, there's two sides to that. There's the conjugate. There's the event where you're creating the event, the trigger, and then there's the receiving of the event or the grabbing of the event. So in BPM talk, it's the throw of the event, and there's the catch event. So start events are always catching. An end event, in this case, the dark circle, is a throw event, which at the end, if we put this at the end of our model, it signifies the end, but it also signifies the throwing that I'm done. And if another party was interested, they could be notified that this was done, and I'll show you how to do that. But how this might start is you can imagine a bunch of other processes that are running and doing a bunch of things. And maybe there's some decision that goes off and it does some assessment and it says, oh, we think this person might be at risk for chronic kidney disease. Well, we could, in that other process, directly call this process or wire this in. But that's not always the best thing to do because there's a coupling there. And so what we're going to use is this pattern of catch and throw in signals. And so I'm going to put on here, I'm going to change the shape. So you can click on change shape and come down, and you can see these are different types of. So at the bottom, you'll see it says start, intermediate, end. But this is the top one, the starting is always the catch, and the bottom here, the darker circle, will be the throws. And then there's different types of catches and throws. I can have a message, someone sending me a message. When you send an email, you're throwing an email. I can have a timer. So a timer is something that, exactly as it sounds, a timer is a special kind of catch throw event that it catches and throws itself. The timer is ticking, right? You set a timer. When you hit this, the timer is 20 minutes. So 20 minutes goes by. As soon as 20 minutes is done, it releases. Escalating is a special kind of throwing event. It's out of scope for this conversation, but this has to deal with if a process goes badly. We always design the best case, but then something happens that we didn't expect. I worked on a guideline that dealt with blood transfusion, and we with great detail processed how they were going to go out, the whole process of everything that had to happen to the inserting of the needle, the time, all that stuff like that. But we had to add in an escalation is because in some rare occasions, the needle falls out, right? And you got to stop the process. You're not going to just keep going on. So this is an escalation where you're saying, hey, something's, we need to escalate. It's a known problem. We're escalating to some other process to take care of. Conditional events, it's a pretty complicated concept. It has to deal with having, you can set up, you have multiple events and you can set conditions on one's valid or when you can get one. Error is just that. If something happens and you get to this part in the process, you want to say, hey, there's an error. There's a problem. Compensation is in some cases, you can imagine if you're going through the whole process of doing something and for whatever reason the process stops, maybe there's an error, maybe there's an escalation or something, you have to compensate, you have to unwind what you've done. So you can imagine maybe some banking financial process where you're going through all these days and days of steps and debiting, crediting, taking money, moving money around, and then the whole thing fails. Well, you have to go back and you got to put all the money back. So this is how you can create an escalation event or a compensation. Signal is the one we're going to pick. Signal, I think the metaphor I like to use is just imagine you're sitting on a raft. You've got a flare gun, and you're shooting it in the air. And that's what a signal is. You're shooting it in the air, and anybody who's interested in such a signal can grab it and work with it. I don't know who's going to catch it. I don't have any control over it. Someone may do it, someone may not. I might get 10 people show up to rescue me. I don't know. I don't care. I just want that signal to go out. Multiple events is you can have multiple triggers that you need, and then parallel is when you actually you need parallel events where you might want two things that have to happen, two triggers that have to occur before you can go forward. These last two are pretty complex, and frankly, I'd be pressed to tell you the last time I used even the parallel one. Although I did just recently have to use the conditional one, which is kind of an interesting scenario. So signal, so I'm going to choose that. So back to the person who was asked a moment ago. So somewhere else, some other process could be doing, somebody comes in for a checkup, whatever it is, they're doing their normal stuff, and some decision or some issue has been identified that they need to be considered for at risk for chronic kidney disease. That other process could throw this event, and this process would wake up. It would be instantiated for that particular event, for that particular patient, and then this whole process could be kicked off. Again, be careful of questions. You get long answers. Okay. So back to our what we're doing. Oops. Looks like so go ahead and copy out of the CPG and place them, the text in the respective tasks. And notice sometimes what also happens is in the guides, the author will munge together multiple tasks. And our mantra is disambiguation and clarity and separation of concern. Don't munge together two different things that, although they feel like they go together, if they're uniquely different, don't put them in the same task. Separate them. And this will lead into the next slide I'm going to talk about. So take a moment and go ahead and do this. Catch up with pasting these things as you see. And while you do that, I'm going to do it too. Oh my God, over.
And Christina just posted a question in the chat.
Okay, give me 1 second to catch up, and we'll take a peek. Computer is misbehaving. So hopefully if you realize you just click on the task, double click left twice, I think you can just paste. Okay. Back to this. Okay, question. On the line of disambiguity, how do you know that medical history and physical exam are part of obtained clinical information? Good question. I think it's a good point. Maybe I could have broken that up into two separate, right? The medical history taking process. Maybe that's good for a case, where there's a medical history taking and there's the physical exam, and we know that they generally happen maybe by generally usually the same care provider, the same person. So that tells me they're going to probably go together, but then maybe not. So a better way of doing that would be to treat that particular step as a case, and you'll see how that manifests. We do the labs. We do actually break that out, right? So taking a lab is actually 4 labs that have to be taken. You'll be able to see that instead we could have had the history taking exam could have been a case. We delegate to that, we go into the case, and then there's 2 separate activities that are in there showing one is the medical history taking, the other one's the physical exam. The other leading into that question is how do you represent questionnaires? There's been a lot of thinking around that in medical history. There's a series of questions you're going to ask. Some of them are pretty, they're pretty obvious, but then others are going to be more as the person speaks or talks, you're going to be like, oh, what about this? And so how do you represent that? And there's some work around using case modeling notation to represent questionnaires. A lot of work in that, and outside of scope, but be glad to share with you some examples. We've done a lot of work at the VA representing templates for one we worked on was for breast cancer. So to answer your question succinctly, probably could have been a case, probably would have separated that into 2 separate tasks within the case, and then one case would have been a questionnaire case where we would have represented the questions and all. So, okay, so I want to go sideways for a second. Everybody in their profession, you learn patterns, or you get exposed to something, and then you learn a pattern, and you learn how to generalize it, and then you use it again. And what's nice about patterns is that they're sort of cheat sheets on how to solve sort of common occurring problems. But patterns also set expectation. So if you suspect that there's a pattern and you see pieces of the pattern that you think that are there, it kind of gives you expectation of what else to go look for to see if in fact it is part of the pattern. There's a paper here, actually I wrote along with others, and in that work that we did, it was by accident. We weren't looking for this, but as we were going through a series of clinical practice guidelines, we started seeing this pattern, and named it the observation assessment finding pattern. Not very exciting, seems kind of obvious. When I shared this with some of my colleagues, they thought it was silly and obvious, but that's kind of the beauty of a good pattern. It's when you generalize it down, it seems obvious. We always knew this, but that's the art. and that's the value of this. So the pattern looks like this, particularly in healthcare. We do some things, but we engage in making observations. And when you take someone's temperature, and it's a little abstract, but you're asking yourself a question. You're the observation you're making. You have a question. You're saying to yourself, what's their temperature? And so that's the observation that you're engaging in. Or what's your weight? What's your blood pressure? These are questions. These are observations we're making. So the pattern starts off with a bunch of observations, the interrogatives, the questions, and then there's a task that you engage in with those interrogatives, asking the questions. Some of them are internal questions. Some of them are, using a thermometer to gather. But you end up with these value pairs, question value, and you get a bunch of them. That's the first step in the pattern. The next step in the pattern is you have a bunch of clinical rules that you've learned. These are like micro patterns, maybe, or things that you've been taught or through or gained through experience. And you've generalized into these rules, and they're abstract. So you have the next task is you get these observation value pairs, and you reach back into your bunch of rules that you've generalized, and you do the decision making with those rules, with those value pairs. So in the first step, we have observations. What is the patient's temperature? What is their weight? And you get values. And then the observation value pairs, John's temperature is 101 Fahrenheit. So that's Celsius. And the infant's temperature is another scenario. The infant's temperature is 99 Fahrenheit. Now we have rules, and I'm not saying these are clinically accurate. I pulled them from different places that they're really meant to be illustrative. I wanted something where the rule is slightly different. So one source says that I found was that adult is considered to have a temperature if they have a temperature of 100.4 Fahrenheit is their temperature, and that greater than that says they have a fever. But the rule is different if they're an infant, at 9.5. So you take your rules, you bind them with your observation value pairs, and you have a finding. You produce a finding. In this case, we say John has a fever. And then that's the observation finding. And then there's some gate that you're going to engage in. And sometimes this gate isn't right next to it. Sometimes this gate happens further on down in the sequence. But this gate is what responds to this finding. And so this is something too. If you're going to be a good BPMN modeler, and it's a common error that people make, is this. This is called a gate. It is not where the decision is being made. This is not where we're deciding if the person has a fever. That's a process. You're engaging in a task. So that gets its own task. This is here, just think of it as like I don't know if you railroad tracks and you've got something where you can pull the lever and it changes the direction of the track. That's all this is doing. This is just a changing of the flow based upon a value that's been determined upstream. Do not put your decision making on a gate. We will laugh at you silently. Right? The decision is made inside your task. Here it would be if fever, go this way. If not fever, go this way. It's as simple as that. And these gates can be more complex, right? You can be an exclusive gate or inclusive gate, which is essentially saying you can have, it's either or it can be, you can have multiple, it can split into multiple directions. These can be complex, and we'll see some gates in a minute. But then, so the pattern is observation, assessment, then finding, and then something else happens. And this pattern can get more elaborate, right? So they can engage in clinical decision in differential diagnosis, you hypothesis, you come up with a new hypothesis, you do a risk assessment in terms of the scenario of like which is more probable and what more severe and all that. But all of that is also a pattern, but the very simple pattern, observation, assessment, finding. If you're going to be building models in healthcare, you're going to see this over and over and over again in different ways. Okay. And what I meant by setting expectation is, I work on a guideline and we're building a guideline and I see all these observations being done. And so immediately, if I'm working with a care provider and they're saying, well, we asked this when we do this and we asked this and we asked this and we asked this, that I know to say, well, what do you do with that information? Besides, there's non-functional things like maybe stored and things like that, but just in terms of interaction with the patient, I know to be looking for an assessment. I know to be looking for these things. And if I don't see them, I know to ask the questions. And if they're not there, I know to ask why. Okay, so back to our model. Go ahead and drop down a couple more tasks. Right? Click on the, let's see, we pull this up. Mine's small, so I'm going to keep cheat. So I'm going to just click on my task. I'm going to choose the blue anchor. I'm going to drop down another task. I click on it, drop another task, and then I'm going to put a gate. And that's partly from, as we look at our CPG, clinical practice guideline, we know there's some things going on here. We've got some tasks being done, right? There's a table 1. So there's some decision making here. At-risk population, there's some questions being asked. Then I know we move on, but then here I see this one here. Does patient have an urgent or emergent condition? And it tells me to go look at table 2. And if I determine that there is an emergent condition, I'm sorry, up here, I have to refer them to the emergency room. Otherwise, I'm going to move on. So look here. I'm going to, so another step that I have to do here, right, is I have to, after I do the exam, right, and this could be a case where I do my exam, it says here, evaluate at risk for CKD, obtain the SCR, eGFR, urinalysis, and I am not a clinician, not medically trained. I don't always, my friends have tried to teach me what these mean, and I have continually managed to not remember. So if anybody is a clinician who wants to enlighten us what these are and the role they play, that would be great, but I know these are tests that have to be run. So I know here I'm going to obtain some CKD labs. So I'm cutting out of here, step 2. I'm going to put it here. And then it says, does patient have, so I'm making a decision here. So I'm going to, at this point, does patient have an urgent or emergent condition? And after that decision, I'm going to do something with the information that I just acquired. Remember, no decisions are made on gates. The gates respond to the decision. Yes, go this way. No, go that way. So let's see. How come the second task assessed does not include the business rule box to show? You're gonna take away my excitement. We will come back and do that. I'm just laying down. So the question is so we can adorn the model with additional information, which will link together the other models, which we will do. For now, we're just trying to lay down the sort of the tapestry of the process model. So we will. So here's where you're going to click on your gate left and drop down a throw event. Remember, a throw event is throwing something. The question is, what are we going to throw? And we'll talk about that in a second. And then on the other side of that gate, pull a sequence and drop a task. And so gate is going to be where we respond to whatever the finding or decision was. Does the patient have an urgent or emergent condition? And you can, on the model, as you put these things, drop these down, let me show you this. We'll throw a throw, and we'll put a task off to the right of this. You can label your text. If you click on the line, it's a little, there you go, so get an arrow. If you double click on the line, you can put some text there. In this case, we're going to go this way if the answer is no. So I'm going to type in no. And, oh, actually, I'm sorry, I got that backwards. This is the way we're going to go this way. We're going to throw this event if they do have an urgent condition. And I'm going to go this way, click on the line. If the answer is no, they don't. And so to just add some clarity here, I'm going to paste that in. I'm going to put that here. And what I'm going to grab this here. I'm going to throw a signal. I'm going to throw it, and I'm assuming, which we shouldn't, but when you architect your solution with these methods, you do have to manage all your process models. You have to keep track of all the events that you're using in your domain, right? And so you should have it's outside of scope of BPMN, but have a spreadsheet with all of your throwing events, and then have a spreadsheet with all the events, all the models that catch, so you wire all this together. And then a good environment will help you track and thread it together. But I'm going to click right on this. There we go. And this is going to be my signal that I'm going to throw. If you click on the text, click on the event, I'm sorry, trying to get that little yellow anchor there. If I get that, I can move that out of the way. All right, so click left, click right, change shape, and we're going to use the signal. We're going to throw a signal. We're going to shoot a flare in the air. So I'm going to choose that. Notice it's a darker circle. Oh, and it just moved my text over. That's a tool thing. See if I can pull it back over out of the way. It's sitting on top of my sequence line, which has the, oops, well, I got that out of the way. All right, try it again. Oh, I pulled the whole sequence line. Okay, all right. Oh. All right, I'm gonna give up. I was trying to pull the refer to emergency department off so we could see it more clearly off of the sequence line. I'm not gonna spend a lot of time on that. What is significant and important to know is that this signal that's exactly what it's called. That text is important. So in a runtime environment, if there was a catching signal that had that exact verbiage, and we threw this event, that other process would catch it. So the naming is very important. This isn't just for the reader's convenience. It actually is, it has runtime semantics. So there's how we show that, does the patient have an urgent or emergent condition? If the answer is yes, we're out. We're not going to continue any further, and we're going to send them on their way to the signal gets sent out, and then whatever process that handles that would pick up, which might, other people might, it might signal other people to come in and start engaging another task that moves them from this location to another location, whatever that is. And there might be multiple processes that get kicked off. There might be another process in the emergency department that will get notified at the same time, so they know this is happening. So continue down. We're getting to the top of the hour. I'm gonna take a shorter break here. I guess I was a little gracious. Try to get your model up to this point. I'm gonna pick up the pace a little bit. We're okay on time. Actually, we've got lots of time, but I also don't want to belabor it. So if you would, continue to work through, get up to this point, and then go ahead and just take a short 5-minute break. And I promise to give you a longer break after this one. I'm back at the top of the hour. Work on adorning the tasks. I'm not going to go much further into the BPMN model. We've hit everything that I would hope to hit to show you, just to give you an idea of this. It's just to manage expectations too. A normal class, if you were to engage in a class on how to use BPMN, I've never seen a class less than 2 days. Usually it's about 3 days, where you have labs and you go through and you learn all of the intricacies of what BPM has to offer. There is a lot more, like how do you wire in your script? So there's a lot. So we've covered a lot.
Question for you.
Yes.
I can't save because it says I have read access only to the repository.
So you should, so going back to let me pull my screen up for you.
Yeah, so, I go to save as.
Yeah, but so you want to navigate under your name. These are all locked. Your name is a folder. So if you click, you should see when you say save as or save, you should be able to navigate. You should see your name. If you click on your name, and then you write save, it won't let you save under your name.
No. So if I go through my name under places, and on the right side it's got my name, and I can have, first BPMN drawing. We try to save over there. No, it does. Okay, sorry. I tried it on the left menu. It wouldn't let me do that. Okay, got it. Thank you.
Okay.
Sorry.
So at this point, go ahead. Oh, what happened to back to my presentation. Go ahead and save your model, but go into the workshop and open up the chronic kidney disease model under the workshop 0. So I just went in, opened that up. Excuse me. There we go. So this says this model has it pretty all the major pieces laid out. Yeah, I guess I already told you that you can. I got ahead of myself. I think normally we would have used this model. I would have brought you to this model to go in and go ahead and add all your activity types. But that's okay. If you get part of the way, you'll be fine. So we're gonna pick back up in just 5 more minutes, 20 past. You have endured this long. But purposely. Go ahead and load up the, go into the second folder and load up the BPMN model out of that. It should look like this. And voila. If you would, we sat and went through all this, this is kind of what we would have ended up with. Some things to just see that we didn't talk about. Notice this little tick mark dash on these sequence lines. That's if you click on a sequence line, you can actually set what's called the default path. So that tick means that for whatever reason, and I don't know why that would why this would happen, but if you got to this gate, there was no yes and there was no no, go this way. I don't know how that would happen, but it's a way of setting the default. So that's what that symbology is. The other thing you see here are notes. I just grabbed and put notes on for help with clarity. Notes have no semantic bearing on the model. They're there for the viewer, the reader. They're there to help people sort of understand. I would use as many notes as I think is necessary to help people understand what, again, we're trying to disambiguate, so trying to add clarity. Those are the only things that, well, I guess the outer step, we didn't talk about pools and lanes. The outer section here, is called a pool. And a pool is, it's contained, right? It has semantics. So everything that you see inside of this is in that pool. And I'm trying not to lean into technology speak, but it would manifest as its own process. It has its own identity. Everything in this is aware of everything else. It's all there. It's all in the same computer, same process, or same organization, right? So if you were trying to show the modeling between organizations, that this might be the marketing department and the other might be the finance department. It's meant to mean that everything is happening in there. Inside is the lane, and the lane has no runtime semantics to speak. I'll come back to that. It has loose semantics. The lane is really just to help partitioning within a pool to sort of help organize. So you can imagine if you were trying to model how care is being delivered in your clinic, you may have a pool called clinic, and you may have 2 lanes, one called doctor and one called nurse. And so one lane would go across the top, one other lane across the bottom. Both lanes are in the same pool, and you would move your activities across those boundaries to say, okay, to show that the nurse is doing these things and the clinician's doing these things. When I said there's no semantics, that isn't. It's partly true. The lane, you can use lanes as showing the role of who's going to be doing what. And some tools recognize that as how you would configure the roles. So, okay. DMN. Oh, I promised you an exciting tour of the Rmg site. Very quick, very quick. If you go to www, oh my God, that's who my daughters still think I work with. You'll see this site. And again, I just want to show you the tree within the forest. Across the top, you'll see specifications. And then within that menu, you'll see adopted specs. So these are specifications that have gone through the Rmg process. It's a whole another story, that are accepted, ratified, industry available, open for anybody, free specifications. If you click here, these are RFPs that have come out. RFPs are requests for proposals. We submitted an RFP. It's a document of requirements for Pedigree and Provenance. So if you go on the RFP here, you'll see under there Pedigree and Provenance. But adopted specs are specs that have gone through the entire process in their specs. Let's click on that, and there's a bunch. And so if you just kind of scroll down, they organize them. A little bit of other OMG speak. OMG is divided into two sides. There's domain and platform. Domains are things like finance, healthcare, banking, domain-specific verticals, manufacturing, space. Platforms are things that are for specs that we are believed that could be used across all communities. And so there are platform specs and there are domain-specific specs. If you come down here, you'll see a list, and eyes are always fail me, so I'm just gonna search for BPMN. Oh, there we go. Right, so we see decision modeling notation. If you click on this, and you can look at all this fun stuff, groups that are involved in working on this. But here's the thing of the note right here, specification. Click on that, you get a free, well, I should say you send me $1. This is the spec, 261 pages. Can't sleep, leave it by your bed. It's very dry. It's a lot of boilerplate stuff. Again, this is for tool vendors who are going to try to build a tool to implement or use these models. And so it goes through and it'll explain all the semantics. But what is good is it does show you, if you're just a general consumer, it shows you what the symbologies, what it means. And this is all free. So it's a good resource if you kind of have a question about something and not quite sure. And this is really straightforward. This is not very technical. It shows you some of the different relationships and things like that. Where it gets to be terse is you start looking at this kind of stuff. So when you're looking at those pictures on the screen, that square or that line, there's underlying semantics, and there's things that line can do or not do, and there's relationships between the head of the line, the tail of the line, and what can the head of the line touch, and so on. That's what this is all going to start talking about. This is called the meta model. This is the underlying model of what underpins all that. So when you're building that DMN model or BPMN model, you're writing this kind of stuff underneath the covers, and this is what makes this stuff executable, because it has the semantics. Okay, that's it. Just want to make you aware of it. So DMN, decision modeling notation. Let's get started. You're going to Jumpstart. You're going to click on the palette, the little tile, the D, and you're going to see this. We're going to pick up the pace a little bit. So, okay. So let's look back one thing. So we're going to look at this step right here. What is the stage of CKD? And when we look at the clinical practice guideline, that's this table right here. So in this flow, up to here, complete clinical assessment, determine stage of CKD. Table 4, this task, which we've now modeled, we have in our process model, we put in here, what is the CKD? That's what we're now gonna build this process decision model using DMN. And that's all based off of this table right here. Stages of CKD. So this is going to be our friend for the next 10, 15 minutes, maybe 20. So you build your DMN model. And so so stay with me on this. Don't get ahead, because the tool will do some things to make life easier for you. If you get ahead, you can still do everything. You just have to do more of it by hand. So as tempting as it might be to click on things, wait. Otherwise, you'll get to click on a lot more things, and it'll be tedious. So the two major pieces is the data object, the data input, the thing that we're going to, the data that we're going to be working on, and the decision. And so we're going to grab an input data, pull it over. Don't do the second part. You'll understand why, and we get there. Right. So click on input data, drag it over, and you can give it any name you want. I put in EGFR lab report. So we have to describe the data that we're going to get, that we're going to work with. And this goes back to when I talked about the shared data object, right? This is what the shared data object spec is going to hopefully help make better and more fluid between the different models. So, but for now, you're going to click left on it. You're going to change, you're going to say input data type, and you're going to see this dialog box pop up. We have to tell the system what kind of data we're going to be working with, what kind of decision, that the decisions are going to work on some kind of data. What kind is it? The default is just text. So there's a little chain link here, right? Click on it. You're breaking it. That's their metaphor. So you click on that, and you're going to see something like this pop up. And what we want is we're going to be working with a number that's coming from our lab. So choose number. You're going to click on simple, choose number. Let me catch up with you. Open up a model, BPMN. Waiting for my model, my environment to open up a.
So are we in the second BPM plus Jumpstart under
Yes,
decision modeling?
We're in the decision modeling at this time. Did you need help catching up?
Well, when I open it up, it gives me a whole table with the GCFR and CK stage, etc.
Yeah, no. You want to open up a blank. That's the answer, I think. So just go ahead and click on File, New, so you get a blank palette like what you see on the screen here.
Roger, got it. Thank you.
Yeah, that's the answer, which you can. That's certainly fine. So I pulled over.
Sorry, I didn't peek.
That's okay. So I'm just gonna. I've got my EGFR, I think is what it's called, and I click left. I change. I choose attributes, input data type, and I'm going to change this from text to click on simple, number, and then I just hit close, and that brings me to here. Everybody at this point? Okay. So now I'm going to grab a decision. I'm going to pull it over. And what do we call it in the present? We call it CKD stage. Okay. Yeah, and this is supposed to be the lab report. So maybe I'll just change out the lab report, UTF. And then this is the decision we're going to be making off of this is the CKD stages or stage. Now, the data objects can be used over and over again. Right? Matter of fact, if you're building your own models, what I'll do is I'll create a separate model where I'll just keep all my data objects in, and then I can reuse them to thread things together. So this EGFR lab report could be used again elsewhere. But now I want to show that this decision here, this CK decision, is going to use that. So I got to choose the information request. I'm going to grab that here, pull it over, and that my data is going to go into this decision. So I'm going to put that here, the head. I'm going to grab the tail and put it down to here. Now, staying up with this at this point, the reason is that the tool is smart enough that when we start building the decision logic in here, it's going to go in and evaluate this data object, and it's going to do a little bit of housekeeping and make things a little easier for me. That's why I was cautioning you to sort of wait up until this process. So now there are different types of decision support that are provided under DMM. The one that we're going to work with is so come on, click on the decision, choose attributes, then choose the decision logic. We're going to assign the kind of decision logic we're going to use. So attributes, decision, and here's the list of them. We're going to use decision table. Fortunately, we don't have time to get into these, but just know that you can express some very, very interesting and intricate complex decision making with adding these all together. I'll put some examples that you'll all have access to. Like there's a BMI example which shows you how to use some of these. I'll give you access to those. You guys can take a peek at later on if you so are interested. So I'm going to choose decision table, and this is what I get. And notice that let me zoom in a little bit. No. It already looked and said, oh, you're using an EGF lab report. And so it added that for me. That's the nice thing. If you've got like a really complex data object, it's nice that the tool will sort of pre-populate all this for you. It prevents you from having to do it all by hand. You can certainly do it by hand if you want. That's why I wanted you to wait. So what do we see? This first thing here, the number 1, that's a rule. So rule number one says nothing. This is, you have inputs to the rule. You should see the word inputs, and then you have the result, the outputs. So the output is what gets presented, pushed forward if the input side evaluates to true. So the input to this rule is the lab report. And so I'm going to look at, and it says, if we look at this table, it says, all right, if the EGFR is greater than or equal to 90, then you're in stage G1. If you're 60 to 89, you're in stage G2. So G2, G3A, G3B, those are our outputs. This is our decision. If this, then that. So let's look at the first one. If G1, I'm sorry, if the EGFR is greater than or equal to 90, then G1. So let's do it. So the first part says what? It says if greater than, equal to 90. That's it. And if that's true, the answer, you're going to be G1. Oops, that's the state, the stage you're in. That's it. Rule number 1. If this is true, then this is what the results are. This little plus sign here is going to allow us to add the second rule. Click on it. I'm going to say the second rule says, this is interesting. It says, if you're 60 to 89. Okay, so there's a certain language and syntax that you have to use in here. It's called feel. That's what that little F stands for. That's telling us that the parser is evaluating that that parser is evaluating that cell with the field syntax. So it'll give us syntax errors if we violate it. We can turn that off, but let's leave it on. Now, if you want to get a feel for some of the things you can do in terms of logic, click on this little logic here. You could and ors. If you're going to be manipulating dates, testing dates, these are things you can do, so on. We've got an interval. So some of us, you might remember back in the math class, interval is the way we express that is the first number, and then it's dot dot, and then the next number. In this case, it's 89. Now, what it says is that if you're, so you can say include or up to, and that's done with either a brackets or a parentheses. A bracket means up to and including, or including. So this says 60, including 60, all the way up to 89, right? That's the range. And if you don't do it right, it'll give you ugly colors and tell you something's wrong. And so this is going to be G2. Okay, I'm going to stop here, and you all take, 5 minutes and add some more rules.
Okay, so how do you add a row again?
See the little plus sign right here? Right here.
Right.
So click on it. If you don't like
that's
it,
column, but I mean, oh, okay. Oh, yep. Thank you.
okay. Our rules here. What's it say? It says if it's, I'm going to put bracket, it says 45 dot dot 59. Your G. Okay. This one's going to say 34. Oops. What did I miss? Okay. So let's see. Let's see if I got that right. So greater than or equal to 90, G1. The range is 60 to 89. Yes, go ahead.
So there's a question on the last one where you have less than 15, and actually the guideline says G15 if it's less than 15 or dialysis. So both of it's an either or input, not an output.
Yes.
And yet I think what you had is you have if it's less than 15, then it becomes an output of dialysis. But to me, it would seem that you would need a second column of inputs and have one that says dialysis. And in the event that that's true, then that becomes G5 as well.
I think you're correct. So we'll fix that.
Okay.
Because I'm not sure who was speaking, but as you're pointing out, we have inputs that are numeric, but we have one where there is no numeric. It's just they're telling us this person's on dialysis, so therefore it's G5. So we don't need to have the score. But there are other problems too. Anybody see any other issues? What happens? It's 89.3. Doesn't say. What happens? It's 44.7. So there's some ambiguity in this. In addition to the logic error that I introduced. So what we need to fix this, well, so before we get there, so those are things we're going to lean into in a second. So you see the rules. Now, the other piece that we have to I want to make you aware of is this little yellow box here. This is called the hit policy. This is how we tell this when the system interprets this table, when we process this table, this hit policy tells the interpreter how to view these rules, right? Are all the rules applicable? Do we just run until one rule is true? Can more than one rule be true? What happens more than one rule is true? Is there a precedence? Is there a priority? What do we do with the results? That's all under hit policy. So here, if you click on this yellow, you'll see this pop-up box. It says hit policy. And right now it's set to U for unique, which means that all the rules, all the antecedents, the if parts have to be unique and different. You're not allowed to have, with this policy, you can't have two rules that have the same antecedent. So I'm okay with that. Priority first. First is keep running until one of the rules fires. The one we're not going to lean into, and that you'll see this in the examples I'll leave you with, is another thing you can do is what's called collect, where you allow more than one rule to fire, and then you collect up the results, and you can give back the list. Like these are the answers, these are the results of 3 things firing or 2 things firing. Or you can also say what to do in the sense that you might say, well, how do you want to aggregate the results? I want you to collect all the results, and then I want you to, let's say that, like if it's a calculator, like an APGAR score or something you might be familiar with, or is you add up all of the values of the rules that fired, and that sum is the answer to the calculator. Or I want just the minimal one, whatever. Go through the list, and whatever the smallest number is, give me that one. Or tell me how many rules actually fired. But for us, we're going to just go with unique. Okay, so we still have some issues, but let's see what we got. We got 6 rules. Rule 1, greater than 90, tell me G1. Rule 2, right? So I told you we can run things. So the tool's smart enough to do some work for us. Click on execution, the top here, and test. And it knows what inputs we can have. In this case here, it gives us a little drop down and it's expecting a number. So if I type in the number 65 and I hit run, fingers crossed, make sure let me say, I think we'll be okay. Let's hit run. And we see what rule fired, rule number 2. because 65 was in the range of this range, and so this decision reported back G2. Now, if we come back to our BPMN model, well, I'll come back to that, right? You can imagine hitting this, the data goes into it, it does the calculation. The output of this decision is what comes back to my BPMN model, and now I can have a gate that reacts to the answer. We can go a different direction. We can change the flow based on this decision. Let's try one more number. Hit back. I'm going to put in, let's put in 29. Run. And then we get, we expect rule 5. Now, let's see what happens when we do this. What happens I put in, well, up to, say I put in 29.5. No, because look at our rules. There is no rule that's going to fire if the if part antecedent of that is 29.5. None of the rules fire. So one of the things we can also do is if we click, I think here, there we go. So I clicked on the, right below it says CK stage and it says text. I can set up what's called a default value if all the rules fail. So I'm going to click on that. And the default value is, I'm going to put error. Right. And so now if I run this, oh, still got an error. Can get error. I would expected this to say error, and I don't know why it did that. Did not do that. There's one thing I didn't do, which I, as a good modeler, I should have said what the output type is here. I didn't think I needed to. I'm just going to set that because that might explain why it got silly. Sometimes it does affect things. I'm running it again. Now I'm going to have, oh, I lost this. So the default type, let's see, say error. Maybe I didn't get that right. Again. There we go. Error. So that catches if none of my rules fire. None of my rules fire. All right, so let's look at this problem, right? So the guide didn't take into account the fact that we're not going to get integers, we're going to get reals. So let's look at the guide and we'll see. So 89. So here I'm going to change this. I'm going to say I'm going to put 90 and put a parentheses. What that means is that means including 60 all the way up to as close as you can get, but not including 90. And then I'm going to do the same down here. I'm going to thread this and I'm going to put 60. So 60 is not going to, this rule won't fire on 60. It'll fire all the way up to 60, but not on 60. So I'm going to fix all the way down here. So that's an error in the guide, I think. And the last one, 30. There. So let's run it. Let's go back and do it now. Let's use the same 29.9, 29.5 run. We got it, number 5, just as we expected. So now the other problem was our problem, my problem, right? I left out the fact that the EGFR lab report apparently doesn't just return a number. It could also say, hey, this guy's on dialysis, and there is no number. So I've got to account for that in my data. So I'm going to come back to my data object. I like to cheat. And what I find here is I don't just have a simple number. I actually have a more complex structure. So let me show you how I got to here. I went back to the, you click on the tabs down, like these little, there's tabs for the different, you click on the bottom here, that's the table, that's the decision model. Click on this first one. Clicked on that, I click left, I click right, and eventually it'll catch up. There we go. Attributes, input data type, and I have number. That's not going to work. So I'm going to break it. And I have, so this is, you know, a little bit of programming. We're going to create a data structure. So it's a complex, it's like, it's a report, right? It's got multiple columns. I need fields for each of the types of data I'm going to collect. So what I have is I'm going to create a new type, because it's not one of my simples, right? These are the all ones that I get out of the box. I need a special one that's uniquely for me. So I'm going to click on new, and it's more than one thing. So there's some structure to it. So I'm going to click on structure, and I'm going to have, now I have the EGFR, which it is still a text, but I also have this notion of them being on dialysis. And so I'm going to treat this as a question. Oh, hold on. Yeah. On computer. Is on dialysis, question mark. And so that's going to be true or false. In this case, the true or false has handled the notion of a Boolean. And I'm going to call this my T for type report. Save.
Robert, this is Bruce. Actually, when I look at the guideline, it looks like, you know, this is meant for primary care providers. And so if I would probably put in the initial clinical information, or at risk, if it's a known CKD, particularly known dialysis stage 5, that you would bypass most of this logic. If someone's on dialysis, the EGFR, of course, isn't really valid, which is what most of the comment text says in that lab report. So it probably belongs in the initial context at the beginning. When that's inferred or implied by the guideline, you have to sort of say it's a primary care focused guideline. So it wouldn't really be relevant for dialysis patients.
Okay, appreciate
that's
that.
A clinical detail that's, you can handle it this way too, of course, but typically you would exclude dialysis patients or known CKD, patients, particularly advanced stages.
Thank you. And so, when I'm when we're working with care providers, like with Dr. Bray, I would show him this and he would do just what he did. He would explain to me kind of what was going on and how this is supposed to be. And then we might even move that decision, right? That decision point of, are you on dialysis, way up front, and break it out to a completely different decision. And that's part of the methodology, right? And also the value, because these models are very iterative, very flexible. I could keep one copy and say, well, this model is per the policy of the VA. This policy is per the Intermountain Health or University of Utah, and I can have, I can accommodate sort of different nuances. So I appreciate your feedback. I do want to show how this would manifest in the decision making, just for education purposes. So I'm going to close this, and so now I've got that information. Now when I click on my decision, I can get there by clicking on this little grid here, or I can do it by clicking on the tab. And now nothing there, kind of not very, very helpful. Well, this is where I have to do it by hand because I've already built my table, and I can add another column. I know there's a column there that deals with the dialysis question. So I do that by clicking on this plus sign right here. And then if I click in the blue here, and I start typing the name of my data object. Uh-oh. Come on, sometime in here, I thought it was going to finish for me. Maybe not, get all the way up to that point. If I get to the end and hit period, there we go. It's showing me what's in the structure, and I'm missing this right here is on dialysis. So I'm going to choose that. It's a Boolean. Now, the first 6 rules, so we actually have 7 rules, and that one says that this is that it's true that they're on dialysis, and so I'm going to put them in G5. Is what the rule says. Now, there's a little bit more work to be done. BMN doesn't like empty cells. We have to tell them how to interpret this cell right here, this first one. And the answer is, I could say the word false, right? I could put false, or I put I don't care. So the dash means I don't care, 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 right? This rule 1 says if you're greater than or equal to 90 and you're not on dialysis, you get G1. Rule 2 says that if you're 60 or up to, but not including 90, I don't care about your dialysis status, then you're G2. Which, according to Dr. Brea, that really wouldn't be accurate. We probably do want to say false. We want to make sure they're not on dialysis. So I can come back here and I can say I can choose false. I can leave those don't care. Now I have to do this down here, right? This cell doesn't have anything in it. I have to put something here. I'm going to put, this is where I don't care, right? If you're on dialysis, you're out, you're done. Now there's another challenge here. Well, if we do these all false, then I think we'll cover ourselves. If I left these don't care, I don't know. Is it possible we could have got a lab report back and they were on dialysis and it didn't? I don't know. But here I'm going to be very explicit in what I want. Right. So now I've fixed per the table what the table says. So now I'm going to run this now, right back, and now notice that the tool has given me choice is on dialysis. I'm going to put false, and I'm going to put 91. Oh, and we got an error. What did I do? This is not. See, no, up to including 90. So the tool also provides error or checking. So maybe I just did something wrong. I'm going to come on DMN and then click on validate and have it take a peek at my model. And it says there's no errors. So, okay. But it doesn't like my, so I get an error. Let's see, execute. Let's try it again.
Robert, I think it's because we changed the input attribute type to text, but I think it should be number.
Did I set it to text? I thought it did it reset to, did I do that by mistake? I'm sorry, let me go back.
And do you also need to put the dot EGFR in your
1 second.
blue header?
That might be that actually because I added a complex structure, I didn't fix that. Let me edit this and see. Oh yeah, see I've got it. So user error. My EGFR, I've got text. That's not right. So I'm going to click on that. I'm going to break it, and I'm going to make it a number. Close. Okay, that looks better. Save it. Close. And I got to clean up my. Come back up here. Click on my decision. And then, yeah, so remember I broke this up into a complex object, and so I didn't finish. I'm going to tell it what this is. So this is EGFR, and that knows that it's a number. Why is it giving me red? Okay, I think, thank you. All right, let's try it now. Back and run. Yay, all right, greater than 90, what did I put, 91? Yep, and it's not, yeah, so that makes sense. Let's back up and try another one. Let's put 40. Yep, it's good. And let's go back and say, oh, this person's on dialysis. Yep, there we go. So there's an example of where we've used DMN. This is executable. You can deploy this. There are tools, there are environments that actually, just like you run a program and you deploy it to your runtime, you can deploy this to your runtime environment, and it can be made available to run and execute. You know, these rules can be pretty complex. Here's the determine BMI. There's actually two parts to it. The first is you got to determine the BMI value, which is a function of weight and height. Here's the model here. And so the actual BMI calculation is a formula. So remember, there's other types of logic that you can run. Remember, I told you there's more than just tables. We can have formulas. Oops, not that one, this one. So there's a formula here. This formula says it takes in a height value, a weight, both of them are numbers, and then this is the function. So this is your H and your W, and it's calculated as a weight divided by height times, or squared, and that whole thing times 703, and then it just truncates off any anything after the decimal point, gives you back just an integer. That's what that's doing, right? So there's the calculation. So this here is showing us how this decision here, the BMI categorization, uses that formula in its decision making. So you can have many decisions that rely and use each other, reuse. And just to show you a little more complex, so this also is a function. You pass in a height and a weight, and the first thing it does is it calls that determine English system mass index, passing in the H and the W into the field, into the function with the variables height and weight, does the calculation. Calculation is bound to the BMI score. This becomes a variable. This variable here then is used down in this table as a lookup in this column. So it comes in here, right? So if this calculates as 18 even, just 18, right? If less than 18, so rule 1 would fire and I would get back a value underweight. But if the calculation came back with a BMI of 30, they would say you're obese. There's an example of a more, and you can get much more complex than this. Okay. That's taking us through the DMN. We're gonna just take a little short break. And we're gonna get into the last section, which is the case management modeling notation. And here's actually, so we actually did take that guideline at the VA and really did flesh it out. And so here's more of you can see the tables and decisions that are being made and the different labs and reports and how one decision feeds another decision. These outer box means that these are actually exposed as services. So you can call this service if you pass in this data into the service. You can run this as a service in your enterprise. This is just, oops, got a little ahead of myself. That symbology there is just, it has no runtime semantics. That's just for if you want to say, okay, this decision logic is based on this report or this artifact. You can adorn your model with these to show the reader where they can go find the supporting documentation and things of that nature. Again, these are just texts. Just trying to show you that you can have, this neurophology. Can't say that. Sorry, nephology. It actually involves 3 other decisions that use other data objects or other decisions. So you can see where one decision can feed many other decisions. The BMI, I showed you that example. This. Another one is APGAR. I always wonder where the name APGAR came from, right? It's actually Dr. APGAR. I just learned that. And I guess he worked the acronym. So the APGAR is one of the first tests that kids get to take. It's a newborn. Appearance, pulse, grimace, activity, respiration. That's where he made it fit his last name. It's a calculator that's you answer some questions and you get some values and you add them up and then you get a number, and that number represents the status. So I just want to show you this because this is an example of an accumulator where I know you can't see it very well, but you've got the first question is are they pale or are they pink? And if you're blue or pale, that's the rule that fires, you get a 0 added to your score. But if you're completely pink, you get a 2. And so here's an example where you've got 6 or so, I think 6 rules, 5 rules. You have 5 rules or 5 categories, right? This is the first question, the second question, and you just all these could fire. You collect all of them up, and then this is accumulated in sum. So if let's say you got the highest score and everything, you would get 10 or no, but yeah, 10. So if there are 5 sections. Yeah. So the sum, it sums them up. So I'm just trying to show you the notion of a collect and sum calculator. Okay. Just take a short break, about 5 minutes or so. Come back at 20 past the hour. Or an app server, something has to run your code. BPMN, DMN, CMMN can also run. You can deploy this to engines that will run these and do all the things that this semantically says, that if it hit this part in the process, it would throw this signal out to all the other processes, and the engine would know about all the catchers that were interested in that, and it would thread it all together for you. And they're open source. One of the open source products is by JBoss, JBoss. And in that, there's a product called Bpmn, JPM, which is the runtime environment, which would allow you to deploy this. Now, there's more work to be done. You have to set up your users and security and roles and all that kind of stuff. But this is very close to being executable. And as such, we can actually run simulations on this. So the tool runs, you can click on simulator, and I can click on here, and I can, oh, that's not what I want, sorry. They changed the name. One tool is called execute. I meant the animator is what I wanted. Animator, and I can hit start, and I can step through this with you. I can say, okay, we're going to step here, and I can simulate this running. Okay, we got an event. I hit this. Okay, we do this work. Yeah, we come here. Now, this hasn't been threaded together. This particular task has not been threaded with the actual task model, the decision model. Notice this little notation here. This has been threaded with the case model. So I can go into if I click on this, it's going to delegate now. I'm going to step out of this and into my case, my case model. But this sits behind this. So I can sit down with a user and say, okay, this is what we're pretending like we're running. But this can be deployed and executed just like you deploy a program. And so now it's showing me the case model, which we're going to build one, and it won't take us long. It's about just a very quick one to build. And then we'll be winding up. So this is showing me the case that we're going to be building, the lab. And I can step into it and run this model. I'm not going to do that right now. We'll come back to it. And I can continue on, stepping through. I just want to get down to the last one. And then I have to make sure I go this way. Down. So stepping through, choosing my path. Okay, here we go here. So now I can be looking here, and then if I choose this, I'm going to release this token. It should, there we go. Now it's going to open up my DMN model that we built. And I can go through the simulation of this and execute it, just like we did before, and get values and come back and continue on. Now this is just animating this, but maybe I'm overstressing it. This is executable. What you see is a picture, but behind this is, well, let's look behind it. All right, so I'm going to do file. Oh, oops, no, I did the wrong thing here. BPMN. Oh, it changed things. And to export BPMN. And where's my cursor? Okay, my cursor disappeared. Oh, there it is. No, there it goes. All right, so I just saved this. But the thing that's I find exciting is it's actually saved out in the native language. Just give me 1 second. Which it's going to be really ugly to look at, but it's computable. Just trying to get over to where it's saved.
I don't know about others, but I feel like maybe your screen is frozen, but maybe you're working on a different one.
I'm sorry. I'm trying to just get there quickly. There it is right there. And then I don't want to open up with the native tool because it'll. I didn't want to open it with XML Spy because it would take too long to load. All right, so to give you an eye exam, but the point is this is the model that's on the screen, and this is machine interpretable, and so just like you can compile and read a program, this is a program that the right interpreter can process and run. So just wanted to show that to you. That there's more to this than, I mean, the first goal is disambiguation and clear dissemination of the clinical information. But by the way, if you do a good job and you use these methods, the product you get also becomes not only the next step beyond is you can actually run simulations against it. And the next step beyond that is that you can actually deploy this to your enterprise if you're using all these different tools. All right, so I belabored that. Okay, so jumping in quickly, we're going to focus here on the case modeling right here. And so coming here, you're going to choose the tiles. You're going to choose the case, which is the green. And you're going to see, oh, there we go. I'm missing a screen. Sorry, I'm missing the screen. We should see the case modeling environment, which is going to be green. So I'm going to come over here, jump with you guys, click on this, choose my case, and then give you a quick tour. CMMN is not as involved. Big pieces are case, and there's the answer. The first thing is the case, the plan. So it's the folder, you bring that over, you've got this metaphor. Pop it down. And the name of this case, this is going to be our lab report. This is going to be where we're running our lab. So I'm going to click on the top of this here. And I'm going to put the, just put CKD labs. And so in the guide, they talk about what, four labs? It's the SCR, EGFR, urinalysis, and then a spot urine. So again, this is a little anticlimactic, not going to be terribly exciting given everything we've done, but it's pretty consistent. Each one of those tasks is, each one of those labs, excuse me, trying to catch up with my notes. Second. Trying to get every nickel. Yeah, okay. The first is you have your labs. That's a task that someone's going to perform. So I'm going to grab a task, I'm going to drop it over. And I'm going to call this this is going to be my SCR lab. And but to kick this off, right, something has to make this happen. I need a document, something that sort of says that this lab is now required or someone should engage it. And so we're going to use the case file item, drag that over. And that's going to be the SCR lab order. Now, you could have one document that's just, CKD labs and all the orders, or you can do, I'm going to do them separately. I'm going to have a different lab order for each, just to make it a little more reusable. But, it could be just one lab order comes in and all these are available. But I have to say that this task is activated when this order comes in. And we do that by putting these entry sentinels, these guards, put on the front here. And then there's a connector, which is this right here on the left. I'm going to connect these together. Drop the head on one side, and I'm going to put this here. And so when this SCR lab comes into this case, this becomes available for somebody to do some work. And I want to make this, I'm going to set this up to be, so I'm going to click left on it. And I'm going to set the type to be a human blocking. So human blocking means that, just as it sounds, is that somebody, you cannot go beyond this task cannot complete until somebody intervenes and does the work. So it's human blocking. At this, I can also, I can also click and change. So now I can change if it's required, right? If it's manually activated. So manually activated is what that little diamond, that little triangle on the side. Is it required? Does it repeat? Now, if I choose required, it means that this task has to be finished before this case can be completed. And that's not really what we mean. what we want to say is, if I get a lab report, then this task becomes activated. It becomes implicitly required because the lab report came in. If I make it required, regardless if the lab report came in, you'd have to do it. So we don't want it to be required. And so I want to say that I also want to say how this lab report, this lab is going to the instantiation of this lab is going to, how's it going to respond to this? Well, it's a result of this lab lab order being created. So I'm going to click on the connector. We change shape. I'm sorry, detailed. I think detailed attributes. Attributes. I'm going to choose click on show standard event, and I'm going to choose maybe. Oh, I hit the wrong thing. Show. I'm sorry, standard events down below. I'm going to choose create. So I did that kind of quick. Let me start again. So I want to tell this task how it relates to the order. And it has a relationship, but this task becomes pertinent when this lab order is created. So I'm going to click left on that, choose attributes, standard event, and the type it's going to be, I click here, is when it's created. Oh, and why is it not showing it? Oh, I unchecked the show. So I'm going to go back here and click on the show. Yep. Now I want to coordinate, but I have other labs I'm going to do, right? So I'm going to just throw these down real quick. In this case, I don't want this case to end until all of them are done. So I'm going to put a milestone just to note when this is completed. The milestones, they're just a sort of, they're just as they are. They're milestones. They don't change anything. They just get hit. And there's a way of kind of controlling flow. So I'm going to put a milestone here. I'm going to call this lab SCR completed. So I'm going to connect these together. And I'm going to set this here also. This is going to be an event. Attributes, standard event, oops, attributes, standard event. And I want to say when this is completed. Oh, you know what? I did do something wrong. I want to, there's no flow here. So it's hard to tell which way, who's waiting on who. So I need to, if you, as a matter of fact, if I validate this, it'll tell me there's an error. I need to put a gate here, Sentinel, and then move this complete onto that. There we go. I would have gotten an error if I checked. And so when I get a lab created, this task becomes available. So you can imagine somebody in the lab, they're all of a sudden the screen, they're going to see this task pop up, and it's in their task of things to do. And then when they engage it, they finish, we'll hit this spot. And so the same is for the other labs as well. So we have another lab here. So you guys can work, at this point, it's the same pattern. So I'm going to add my, my GFR lab. And I'm going to make this human blocking. I need, can't see that far, need my lab. This is the R lab order. Get my guard. Now my other milestone. There's a little bit at the end cleanup here. I'm just trying to, I needed a second one in order to show you. Why did that not light up? There we go. Same here. Hard. Oops. Almost done watching paint dry. On here. And I'm not going to bother with these. I should have, you go in and put these, name the connectors and all. What I wanted to show is, so these tasks get activated, become available, are on the list of things to be done. Oops, spelled that wrong. It's not right either. Oh, okay, whatever. These tasks get turned on when these labs come in. What we want to show now too is that this case closes. So this case has a sentinel that will not let this case close out until this is an exit, right? And so I want to show that when that milestone is hit, it's going to come here and sit on this guard to exit. And the same for the next milestone as well. And so this is a way of sort of holding up this case until everything is completed. When all of the tasks are completed, the milestones are hit, and they'll all merge onto this sentinel, and then you can exit. You can add on these guards more logic. So you can, if you click on these, yes, go on, open up. There we go. I think, no, not details. You can put some control logic, other if then, this value greater than that, the if part, yeah. So you can add logic there that says whatever, that, if some value is greater than 10, then you can go or not go or something like that. But that really is the extent of the case model. Back to the presentation. I've taken you through these pieces here. So this is what the model looks like when we're done. And this is the whole BPMN process. The last thing to do would be just to show you, I'm going to open up the case model done all together. And we can run a simulation on it. So if we run the animator, say start, this is what it looks like. And so this case is now active. You can imagine the BPMN model was running, did all of its things. It then delegated for the tasks. So this information has been sent over to the, getting ready to be sent over to the lab. Notice none of these tasks are open or available yet because these labs haven't been created. When I click on this, that simulates the lab has been, this lab has been, order has been created. Therefore, this task is now available and waiting. And I can say, well, the next task, the next lab gets created. And let's say this is really quick. And so they finish that. And now we're already on to, I said, well, we finished that. So we're going to wait here until these others are done. So I'm going to simulate this task, this order being created. And then maybe we'll finish this one. Same with this, come through. I'm going to release this. He finishes, the person finishes the lab. And then finally, the last one. And so now all of them are done. And so now the task, this case has been completed. And so if this was in the BPMN model, this would close out. and the BPMN model would take over. This is where we ran it. It ran, where did it run? Oh, this is different. This is a different BPMN model. Okay. Okay, all right, well, this is different, sorry. I guess I was trying to show you another example of the BPMN model that was created and then actually is being used and executes. So we've been through a lot. Appreciate your time, it's a long day. As I said, if we were trying to really teach BPMN, that would be 2 days of, each day 6 to 8 hours at the very least. DMNs, get into all of DMN. There's the whole language behind it. There's a field language, there's a syntax, there's more nuances. That would be at least a day, day and a half. Case management, definitely just maybe a half a day. So I just squeezed in a whole week's worth of training in 4 hours. And I appreciate your patience and staying with me on this. Before I turn it over to close out to Dr. McCoy, are there any questions or anything else I can answer before we finish up? Yeah, someone put the JPMB, yeah, I think, well, that might be it, JPBMN, that looks about right, or JBoss. How do we attach the CMMN? Okay, well, all right, easy. So the last question, and one that it is worth just taking one more second for, is how do you thread this all together? And that's a function of the tool. It's not really specific to the languages. So I'm looking for my BPMN model to show you. Here we go. We can use this one. In the tool, if you click on this little icon right here, you click on it, double click left, it'll ask you, it'll let you point to the respective model, in this case, the decision model. So if I click on this little folder here, it says, okay, I can navigate to where that model is, and I can thread it together. And then but that's a function of the modeling tool. That's not a function of the languages. So another tool vendor, Commanda, might do it completely differently. But that's it. You just literally click on the little GIF in the corner. That's how you attach them. Okay. And I might have sabotaged myself. I was supposed to. James, are you on? Jim?
I am here. I'm back.
Oh, okay. I forgot to text you.
No, that's okay. I'm back.
Dr. McClay.
And again, Jim McClay here. I've been bopping in and out of the tutorial, and I'm sure you're all a little worn out. And Bruce Bray, we were just talking about University of Utah and your local implementation of MD Calc. So you see there's a slide up here, but I was going to tell you a little story before I got into the slide, and that is that clinicians like to use decision support tools, but they don't like most of the decision support tools that are built into their local EHR. And there's a few reasons for that, but one of them is that they're usually a little clunky when they're built into the EHR. And there is a vendor that has an app out there, and it's called MD Calc, MDCALC. And I'm not certainly speaking for MD Calc, but I was just left a call with my specialty society where we had been discussing with MD Calc about how do we incorporate some protocols into our EHRs. And one of the issues that came up obviously was the problem of surfacing the calculations in the clinician's workflow so that it isn't, it's both shown to the clinician when they need to know, but it isn't in their way when they don't need to know. And one of the purposes for BPM plus health tooling is to really clarify in the workflow of clinical care where you need to collect and expose decision support tools. So it's not just a problem, theoretical problem that we're talking about here. It's an honest at the table decision right now by healthcare systems trying to figure out how they can collect and integrate these things, and also keep up with the fast changes in practice that are ongoing. One of the examples that was raised just now was in a health system had switched from one type of troponin test to another, and a high sensitivity troponins change the decision thresholds for deciding if somebody has a heart attack or not. And so you need to change your protocol. And the cascade effect of that means that you have to go work with both your cardiology department and your emergency department and come up with a whole new protocol for that. So the practices change really fast, and it gets really expensive when you start to pull together 20 or 30 people in a room to talk through these workflows. So it gets really expensive. So the whole point of trying to come up with a tool set that makes these explanations relatively easy and shareable is really clear when we're talking about multi-hospital systems that are making changes and then need to push it out in their EHR to all these different sites. And the current systems don't support rapid changes like that. And so that's a real problem. So what this BPM Plus is doing is basically creating an open, transparent system. As Robert showed you, the specifications are open and you can download them. You don't need to be a member of OMG or anything like that. And that there's a ecosystem building up around this to make these things available. Now, the vendor community obviously, has a vested interest in keeping the money flowing, and so there's sort of both sides to it, but we really are a healthcare system, and we do owe it to our patients and to all work together and try to improve healthcare. And so there is a large community of practice around that. And because the OMG tool is an open standard and the HL7 tools are open standards, they're supported in general by the Office of the National Coordinator. So it's important that we do those things. So anyway, I just wanted to thank Robert for going through all this work. Want you to recognize that this is a growing community of people that are interested in this topic in various ways. There are starting to be research projects related to this and opportunities to work with our vendors to improve the way we share these workflows and processes. So with that, I was going to wrap up my comments and then just open this up to anybody who has questions or comments, or I'll let Robert decide if, or Terrence decide if it's time to let everybody have a few minutes back in their day. So thanks.
Any questions? We can help answer for you.
So this is Mark again. Sorry, I do have one quick question. I like that, and I appreciate Robert answering the question about the JBPM tool, and it just made me think about how do you integrate like those FHIR calls into that workflow. Is that I'm assuming that's possible to say, the FHIR-based input is this, which goes into this workflow. Yeah, like the example you're showing here, right?
Yeah. So this is just a really simple example that we put together to try to show how to make it real. And so we, you use CDS. Are you familiar with CDS hooks?
A little.
Okay. So CDS hooks is a standard and a method through HL7 around how you can. So EHRs have this monolithic process, and CDS hooks is, if the vendor supports it, is a way to essentially step in the middle of the process, right? So you have somebody that's checking in at the front desk, and then they have that activity in their EHR, and then the next step is they're brought back to the waiting room. Well, that in between there, you can inject something in, and it's CDX hooks, and you can't inject a process, but you can inject basically a call out and a wait for something to come back. And so in the EHR community with the CDS hooks is that the technology to do that. And so there's a process model. Up here we got the EHR running. Down here is going to be your JBPM environment that's all set up, and you've deployed this process model to it. Now inside this one task right here, this get vitals from the HSPC Fire resource server, you crack that open, and there's a script in there that was written that when this gets hit, it does a service-based call. So Fire is a RESTful service. Are you familiar with that?
Yes.
So Fire exposes a bunch of resources that are REST, right? And so this task, the JPPM engine that's running this task, runs the script, and the script, this service task, it's a service task, actually it then has the server, the authentication, all the pieces necessary. It makes a call out of that process space, and it calls a Fire server passing in the patient's ID. And then the Fire server responds back with the information that was requested to this task. It then takes that data, right, and stuffs it into a data object, into this data object here, this vital signs. And that data object then goes into a DMN model. And the DMN model has a bunch of rules that assess the data. And this was about, can they check out? They get a referral, should we send them to the hospital? That's what this decision is doing based on the data the rules that were in here and the data that came back. This decision, the CMMN model runs in this process space, hits this gate, makes a decision. If they're checking out, we create a tell the patient everything's okay card, and that returns back to the EHR, or whatever the case is. So the EHR sent the message over here. Sends the patient ID over, and all this flows. Does that answer your question?
Yes, perfect. Thank you. And with the RESTful services, I mean, I'm assuming that the Fire standard is a requirement. Is that right?
No. Fire is just a protocol that HL7 has developed for dealing with patient data in the EHR. This task could call any service, could call Amazon, right? I could write a process that you hit, and then I can call Amazon services, grab data from them, pull it back, right?
Got it.
Yeah. Yep. It could also call out to, for instance, we have a system that calls out to the National Library of Medicine to convert a NDC code for a medication into an RX norm identifier so we can use it in our decision support.
Okay.
Yeah, all RX norm is a whole library of medications. You can call into it we could call it, you could give me an Rx security code. I can then turn around and call Library of Medicine, Rx, an Rx norm, and grab a bunch of data and pull it into my process, and then continue on my way.
Right. That's an, that APIs can go anywhere, and FHIR is just a layer between the EHR and external systems that was developed by HL7 as a simplification of some of their much more detailed reference information models.
Okay.
FHIR is a lot of things. Trust me, it's a lot of things. Like BPM Plus, it's a whole community of practice and all that. But in essence, it's a specification for wrapping up information models out of your EHR.
Okay, yeah, that's helpful. I mean, the reason I ask is we've got a data science team that uses Python or R, and I mean, being able to integrate maybe some of the models that they're developing would be incredible for us, right? So that's why I ask. They can produce those APIs that we can call.
Right.
Well, if we can be of any help, let us know. Be glad to help you.
Thank you.
Any other questions? All right.
Well, thanks, Robert, for all your hard work on and teaching us how to do this stuff.
Well, thanks for the opportunity. Okay, thank you. Take care.